Section 3.1, 3.2, we talked about molar mass, and we said molar mass of an atom is the same as how many grams 1 mole of a substance would take up. And we said on the periodic table, when you look at the atomic weight or the atomic mass or the mass number, what you refer to it as, it's written as a decimal. And we said that number is the molar mass. It tells you how many grams there are in 1 mole, or 6.02 times 10 to the 23rd particles of that substance. So we used carbon as our example, and we said carbon has a mass of 12.01 grams per mole. That is the molar mass. In other words, in 12.01 grams and 6.02 times 10 to the 23rd atoms of carbon. When you're dealing with elements, the molar mass is very simple. You get it straight off the periodic table. However, most of the time in the periodic table or in chemistry, we end up using what is called a molecule or a compound. So we need to find what is called the molecular mass. The molecular mass is the same as the molar mass, except it is the mass of 1 molecule of a substance. And it'll tell you how many grams there are per molecule, or that molecule per mole of that substance. It's very easy to calculate molecular mass. And it's very easy to calculate or determine experimentally. Let's take water, for example. If we have water in a molecule of water, we have 2 hydrogen atoms and 1 oxygen atom. To calculate the molecular mass, all we need to do is simply take the atomic weight off the periodic table, or the atomic mass, or the molar mass, whichever term you prefer to call it by, and we round it to the nearest tenth. Some places will have you round to the hundredths, some will go to the thousandths. It's really a matter of how precise you want to be. In this class, I expect you to round to the tenths. So, for example, if we have 2 hydrogen atoms, the mass off the periodic table is 1.0. So we take 2 times 1.0 to get the mass of the hydrogen. We're going to add to that 1 oxygen times its mass. So that is 16.0. In the end, we mathematically add up 2 times 1 is 2, plus 1 times 16, which is 16, and we get a molecular mass of 18.0 grams per mole. You would do that for any element given. Now, just as we could use the molar mass to calculate moles then of a sample of any substance or any element, we can use molecular mass the same way that we did molar mass in the previous section. We can use it to calculate how many moles there are of a certain compound in a reaction. And that would be very vital, being able to do this calculation as we move forward into this chapter and pretty much the rest of the year. Let's look at an example of what I mean. If I have 42.5 grams of calcium chloride in a reaction, and I need to know how many moles of calcium chloride are present there, here's how I go about solving that problem. I would take the number given in grams, 42.5 grams of CaCl2. And I would use the same process I did in section 2. I would take 1 mole, which is what I'm trying to find, moles of calcium chloride, CaCl2, over its molecular mass. The molecular mass of calcium chloride, unlike before, I can't just look up on the periodic table. I have to figure it out. So from the periodic table, I look and I see that I have 1 calcium in this formula and 2 chlorines. Calcium has a mass of 40.1. Chlorine has a mass of 35.5. So I take 2 times 35.5. When I add that all up, I get 71 plus 40.1, and it gives me a mass of 111.1 grams per mole. So we calculated the molecular mass. Now that I know the molecular mass of calcium chloride, I can say 111.1 grams per 1 mole. Mathematically, we simply put it on our calculator now. 42.5 divided by 111.1 equals, again, I get a long decimal number, but I'm limited by significant figures to 3 significant figures. When I round to 3 significant figures, I will take my number here, and I would take 3.382 are my numbers, and I'm going to round the 2 based on the 5, and this would become 0.383 moles of CaCl2. Just like before, if I had moles of calcium chloride and I wanted to go back, I would do the same process, except these 2 numbers would be reversed. All right, so molecular mass can be calculated using the atomic weights from the periodic table. But if you don't have a compound, you have an unknown compound, another way we can figure out molecular mass is using a device called a mass spectrometer. And section 4 in your book deals with using a mass spectrometer, and I'd like you to read that section and watch the video clip that follows to understand the process of what a mass spectrometer is. It's a very vital tool to a chemist, and it's best explained reading and looking at the video example.